Assalamu alaikum viewers, welcome back to my YouTube channel Mathenious the Mathematical Genius. As you all know, today's our topic is linear congruence. I have already made a detailed video that what is linear congruence, is it is solvable or not, etc, basic method of linear congruence. If you wanted to watch that, link is given in the description, which is named as episode number 6 linear congruence part 1. This is the part 2 of the same video. In this video I am just going to explain you about some example and a trick to solve the linear congruence part 2 example. So without wasting any time, let's start the video. So we have example number 1. 6x is congruent to 14 mod of 5. First we have to find that is this congruence is solvable or not. So take the GCD of 6 and 5 as it is 1. If 1 divides 14, then this congruence is solvable. So 1 divides 14. So simply this congruence is solvable. As GCD of 6 and 5 is 1, so the total number of incongruent solution of this congruence is just 1. Because the total number of incongruent solution is equal to the GCD of A and N. This is discussed by me in my previous video, which is Euclidean algorithm. You can calculate the GCD of A and N. So simply for solving this, first we add this point by these 3 steps. We just evaluate that this congruence is solvable or not, and we have concluding the decision that this congruence is solvable. So now without wasting any time, let's start solving the question. 6x is congruent to 14 mod of 5. Let's take a basic example. Ax is congruent to b mod of n. This congruence is solvable by the trick if GCD of a and n is equal to 1. And in this question we can see that GCD of a and n is equal to 1. So we can solve this question by the trick. The trick is this: simply evaluate a inverse mod of n. How can we find the value of a and n? Just simply go ahead and take your given congruence and make it evaluate with ax is congruent with b modulo n. Simply compare both of the congruence. You will gradually find the value of a and n, a inverse mod of n. So by comparing this congruence with this congruence, we find that a is equals to 6 and n is equals to 5. Simply calculate 6 inverse mod of 5. I will tell you later that why I am calculating this. Just go ahead and simply calculate this. I am not going to calculate this because it is a lengthy procedure. It will make me massive question, so it will hard to brief on one slide. So simply I go ahead and just writing the answer on the board. So 6 inverse mod of 5 is equals to 6. I have also made a detailed video that how can we calculate inverse modulo. Just go ahead and watch it. You will find the link in the description named as episode number 5 inverse modulo. So because it becomes 6, now what we are going with this 6? Simply we are going to do that multiplying 6 on both sides of the congruence. Why we are multiplying it on the both sides? Simply we know that if a is congruent to b mod n, then ac is congruent to bc mod of n. If a is congruent to b mod of n, then if we multiplied any integer on both sides, it will not affect the congruence. So simply multiply 6 on the both sides of the congruence. 6x multiplied by 6 is congruent to 14 times 6 mod of 5. So by the multiplication we can evaluate that 36x is congruent to 84 mod of 5. Just because to make it 36, because now if we take 36 mod of 5, we will get 1. In the next step you will say that 36 into x mod of 5 is equals to 1x. Just to make this x alone, we will follow this procedure. A inverse mod of n is just calculate to make this x alone. So now x is congruent to 4 mod of 5, as 4 is less than 5, so 4 mod of 5 is equal to 4. So simply x is equal to 4, and 4 is the only incongruent solution of the given congruence. So it is the only incongruent solution. Remember, it is the incongruent solution. We have to evaluate the congruent solutions too. So all the congruent solutions are the residue class of the 4. So simply evaluate the residue class of 4. evaluating the residue class of 4, we have the formula, basic formula x naught plus k of n. At there k is a variable, x naught is equal to 4 and n is equal to 5, which will vary with respect to the given question. In this question, x naught, we have x naught represents the incongruent solution and n represents the mode of value. So n is equals to 5 and x naught is equals to 4. So simply k varies from negative infinity to infinity. Now just simply put k is equal to 0, we have the answer 4. Now if we will put k is equal to 1, we will find the answer 9. If we put k is equal to minus 1, we will find the answer minus 1. If we will put k is equals to 2, we will find the answer 14. And if we will put k is equals to minus 2, we will find the answer of minus 6, and up to so on the both sides. This will continue up to infinity or positive infinity on the both sides. So now simply I am writing these letters in a method minus 6, minus 1, 4, 9 and 14. If we will put any of these integer except in the stead of x, this congruence is satisfied. If you wanted to check, just go ahead and put it, but always remember that this is the all of them are the congruent solution. 4 is the only incongruent solution of the given congruence, because these all can be evaluated by the value 4. So now simply let's take on and move on to example number 2. Example number 2 is 183x is congruent to 5 mod of 31. So simply, as I have discussed earlier, first we have to check that is this congruence is solvable or not. One GCD of 183 and 31 is equals to 1. If 1 divides 5, then this congruence is solvable, and we know that 1 divides 5, so this congruence is solvable. As again, the GCD of a and n is equal to 1, so the number of incongruent solution for this congruence is just 1. Always remember that. So now simply ax is congruent to b mod of n, and a inverse mod of n should have to be calculated by us. Why I have discussed you in the previous slide, just to make this x alone. Now how to find the value of a and n? Just compare this congruence with this congruence, you will find the value of a and n, and this question a and n is equals to, a is equal to 183 and n is equal to 31 respectively. So 183 inverse mod of 31, I am not going to calculate it, I am just writing answer on it, is equals to 10. So how to calculate it? I am again saying that how to calculate it is the link is given in the description. You can watch the whole video that how to calculate an inverse modulo. 183 inverse mod of 31 is equals to 10. So now just simply multiply 10 on both sides. Why? Because we know that if a is congruent to b mod n, then a c is congruent to b c mod of n. If any positive integers, if any integer multiply on the both sides of the congruence, it does not affect the congruence. So simply if we divide 10 on the both sides, we have 183 times 10, x is congruent to 5 times 10 mod of 31. So simply on the left hand side we have 1830 times x is congruent to 50 mod of 31. Simply if we will take 1830 mod of 31, we will have only 1. So, and this condition, I am again saying that we follow this procedure inverse mod of n just because to make this x alone. So in this condition we have x alone, x is congruent to 19 mod of 31, so we know that 19 is less than mod of 31, so x is congruent to 19. Again in this question we have only one incongruent solution, 19 is the incongruent solution. Now for finding the others congruent solution, we have to find the residue class of 19. For the residue class of 19, we again have the formula x naught plus k of n. Here n is equal to 34 and x naught is equal to 19, where k varies from negative infinity to infinity. So simply put k is equals to 0 for the first time, we have 19, which is the incongruent solution. Now put k is equal to 1, we have 24. Now put k is equal to minus 1, we have minus 14. Now put k is equal to 2, we have 29. And now put k is equal to minus 2, we have minus 9, and up to so on the infinity. Again I am writing these answers, these incongruent or congruent solutions in the solution set, so every member of this solution set will successfully satisfy this congruence. You should go ahead and check it. Now again I am moving on the examples number 3. So you can clearly see that in the example number 3, the GCD is not going to be 1. So in this question, you will find that what happens if GCD is not equals to 1. What we will do then? The simple method, there is no more changes, just a one step. 6x is congruent to 9 mod of 27. So if we will take the GCD of 6 and 27 is equals to 3. So first we are just going to evaluate that this congruence is solvable or not. So GCD of 6 and 27 is 3. If 3 divides 9, then this congruence is solvable. We know that 3 divides 9. So this congruence is solvable. And on the other hand, we also know that GCD of A and N in this case is 3. So the number of incongruent solution for this congruence is 3. Always remember that. Okay. Now just simply divide with the GCD every term in the given question. I'm just simply dividing with the GCD. The GCD is 3. So divide 6 by 3, divide 9 by 3, divide 27 by 3. So now we have 2x is congruent to 3 mod of 9. So if we will now take the GCD, because I am dividing it, because the inverse modulo method only works if and only if GCD of A and N is equal to 1. But in this case, GCD of A and N is not equals to 1. So to make it 1, we should do this. 2x is congruent to 3 mod of 9. So now simply just go ahead and find that this congruence is solvable or not. Taking GCD of 2 and 9 is equal to 1. I am not evaluating this because it is a law of GCD. If one of the number is prime and other is not a multiple of that, so the GCD of that two numbers should be 1. So GCD of 2 and 9 is equals to 1. This is my video named as Euclidean algorithm, in which I explained about the laws of GCD. You will find the link of that video in the description too. So simply GCD of 2 and 9 is equal to 1, and 1 divides 3. So simply this congruence is solvable. 2x is congruent to 3 mod of 9 is solvable, and ax is congruent to b mod of n. So is a basic example of congruence, and as the GCD is 1, so we can solve it by the inverse modulo method. So simply GCD of a and n is equal to 1, and a inverse mod of n have to be calculated by us. So in this question, by equating this congruence with this congruence, we can evaluate that a and n is equals to 2 and 9 respectively. 2 inverse mod of 9 should have to be calculated by us. I am not again going to calculate it. I am just writing the answer. 2 inverse mod of 9 is equals to 5. And how we evaluate that, I am again saying that you will find the link in the description. Inverse modulo episode number 5. So simply what we are going to do now, we are going to do the same method, multiply 5 on the both side of this congruence. Forget about this congruence for some time, just take this as a basic. Multiply 5 on the both sides. We have on left side we have 10x is congruent to 15 mod of 9. From the left hand side we can say that this will eventually make 1, because it is 10x mod of 9, so it will remain as x, and 15 mod of 9 will become 6 mod of 9. Okay, so 6 mod of 9 is 6, so simply x is congruent to 6. So 6 is the incongruent solution for this congruence, as we know that this congruence is derived from this congruence. So 6 is also the incongruent solution for this. 6 is also the incongruent solution for the given congruence. So 6 is one of the incongruent solution of 6x is congruent to 9 mod of 27. It's the one of the incongruent solution because GCD of a and n is 3, so this congruence has 3 incongruent solution. One of them is 6. To finding the other two, we also have a formula to finding the incongruent solution. Now for the others incongruent solution, we will use this formula, which is as x dash is equal to x naught plus n over GCD of a and n into, which is detailed explained by me in the previous video. You may say that in the previous part of the same episode. X naught is equals to x naught plus n over GCD of a and n into t. So simply we know that in this case x naught is equals to 6, n is equals to 27, and GCD of a and n is equal to 3. Then what will be the value of 3? I have discussed with you again in the previous lecture that the value of t will varies from 0 up to less than that of GCD of A and N. In this case, the GCD of A and N is 3, so the value of t should be 0, 1 and 2. Now simply put the values of t one by one. All of the other variables are fixed. Just simply t is vary by y one by one. So simply just put t is equal to 0. We have 6, which is already got by this from the method, inverse modulo method. Now simply put t is equals to 1. If we put t is equals to 1, we will get 15, and if we will put t is equal to 2 in this equation, we will get 24. So 6, 15 and 24 are now, these three are the incongruent solution of the given congruence, because we have to use this formula to find the other incongruent solution, and we have respectively find the other incongruent solution. One of them is 6 and the other is 15 and the other is 24. So as I have discussed earlier, GCD of n is equal to 3. So simply these have 3 incongruent solutions. So now for finding the congruent solution of the respective incongruent solution, we have to find their residue classes. To find the residue classes, 6, 15 and 24 are the incongruent solution. For the residue class of 6, we simply use the same formula as I've discussed in second and first slide. So simply x naught plus k of n. Here n is equal to 9 and x naught is equals to 6, where k varies from negative infinity to infinity. Just simply put k is equal to 0, we have 6. If we put k is equal to 1, we have 33. If we put k is equal to minus 1, we have minus 21. If we put k is equal to 2, we have 60. And if we put k is equal to minus 2, we have minus 48, and up to so on the both sides, from infinity to negative infinity or negative infinity to positive infinity. Now I am writing again these numbers or these letters, these integers, just in a solution set: minus 48, minus 21, 6, 33 and 60. These three are the congruent solutions for the respective incongruent solution. If we put any one from this in the given congruence, it will satisfy that congruence too. Now for finding the residue class of 15, we will use again the formula x naught plus k of n. Here n is equal to 15, x naught is equals to 15, n is equal to 9. Sorry for the interruption. N is equal to 9, x naught is equals to 15. K again varies from negative infinity to infinity. Simply put k is equals to 0, we have value get the 15. If we will put k is equal to 1, we will get 42. If we will put k is equals to minus 1, we will get minus 12, and if we will put k is equals to 3, we will get 96. I eventually missed 2. Just go ahead, if you want to put 2, 3, 4, whatever you wanted to put, just put it, and whichever answer should be get by you can be the value of x, and it will successfully verify the given congruence. It will successfully satisfy the given congruence. So simply put k is equals to minus 2, we have minus 39, and up to so on the both sides. So simply I am again writing all of them in a given set: minus 39, minus 12, 15, 42 and 96, and up to so on the both sides. So if I again put any one letter from this set, you will again able to satisfy the given congruence which is given in the previous slide. So now I am now finding the residue class of 24, which is residue class for 24. So residue class for 24 is x naught plus k, and here n is equal to 9 and x naught is equal to 24. Simply the value of x naught is varying because of which the value of all the incongruent solution started varying from residue class to another residue class. Simply put k is equals to 0, we have the value of 24. Now put k is equals to 1, we have it 51. Now if we put k is equals to minus 1, we have minus 3. Now if we put k is equal to 3, we have 105. And if we put k is equals to minus 2, we again get minus 30, and up to so on the both sides. Again I am writing all of them in a solution set: minus 30, minus 3, 24, 51 and 105. These three solution sets and up to infinity, which are ranges from negative infinity to infinity. are the solutions of the given congruence. Remember, 16, 15 and 24 are the only incongruent solution. All of the others are just the congruent solution of the given congruence. Hope you like the video. If you have any questions, you will find the link of my Instagram, the description. Just go ahead and follow it, and you may ask a question any of type in that at my Instagram account. You should have to follow my Facebook page. You should have to follow my Twitter account to never miss an update.